The University of Delaware has been a leading higher educational institution for solar energy research. Much of this has been completed at the University of Delaware's Institute of Energy Conversion. The Institute of Energy Conversion was established in 1972 at UD for solar cell research and development. It is the longest-running university solar research lab in the world, and is also a pioneer in training and educating individuals from diverse academic and geographic backgrounds in solar energy research. At present, 22 students and 16 professional staff work alongside each other on solar cell research at the IEC. UD departments that are involved with the IEC are physics, chemical engineering, electrical and computer engineering, and material science engineering. The Institute is also home to a diverse museum of solar modules that IEC has collected over the years. In this video, we will discuss the history and evolution of solar energy at IEC, as told by the modules housed in its museum. Since the 19th century, it has been known that light can be converted into electricity, but it wasn't until 1954 that the first practical solar cell was demonstrated at Bell Labs. This video clip shows one of those early solar cells made at Bell Labs. Shortly after this groundbreaking achievement, research in solar energy rapidly took off due to the emerging space race in the late 1950s. Scientists and engineers needed better ways to power satellites in space, and by the end of the decade, half a dozen satellites had been launched with solar energy capabilities. To this day, solar cells are widely used in spacecraft and satellites. Not long after the first successful satellites were powered with solar energy, scientists began focusing on developing solar modules for capturing sunlight on the ground. The modules at the IEC Solar Museum cover a range of 40 years, with the earliest items dating back to the early 1970s. The variety of shapes and colors reflect the many different materials and technologies that have been used over the years. Most commercially available solar modules can be divided into two broad categories: silicon and thin film. A silicon solar cell is made by taking a large piece of very pure silicon and sewing it into thin wafers, often only slightly thicker than a human hair. After a few more processing steps, the wafer is transformed into a working solar cell. Early silicon modules have round cells because round wafers were used. Today, the wafers are cut to maximize the number of cells that can fit on a module, which is made up of a group of individual cells. Today, silicon is the most widely used type of solar cell, yet exciting research advances are still being made with this technology. For example, these two modules produce the same amount of power, but the state-of-the-art module in front is almost half the size of a module from the early 1990s. The other major technology is thin-film solar cells. Thin-film cells are made from a wide range of materials that absorb light better than silicon and are about 100 times thinner than a standard silicon solar cell. This provides the opportunity to build lower-cost cells since less material is used. Thin-film materials are delicate, so they need to be supported on a thicker material like glass, metal, or plastic so that they can be easily handled. An advantage of this is that thin films can be supported on bendable materials like foil, and the resulting solar cells will also be flexible. IEC has been specializing in thin film research since the Institute was founded. The museum has many early thin film modules, including a module that was created here at IEC. Like their silicon counterparts, the performance of thin film materials has been steadily improving over the past few decades, and research is still being done in this area. All of this research on these two major solar cell technologies has resulted in 46 patents over the 42 years the IEC has been in operation. As a comprehensive research laboratory, at IEC, solar cells start from design concepts, then undergo processing, and are tested for their performance. Modules such as the flexible module shown earlier are usually processed in house-made systems that are designed and built by IEC professional staff and students. After cells are processed and made into finished devices, they are tested to make sure they work properly under similar sun conditions. On average, approximately 800 cells are tested per month in the IEC cell testing lab. Some of the earlier IEC modules were installed on UD's Solar One, the first house to completely produce its own energy using solar technology. The first practical silicon solar cell made by Bell Labs was advertised as being able to power a telephone. Now solar cells can be mounted together in any configuration to power any establishment, such as this house in Newark, home to IEC senior scientist Stephen Hegedus and family. Direct electric current produced by solar modules needs to be converted into alternating current, used by most household appliances. Therefore, most homes with solar modules are equipped with an inverter. Furthermore, these homes are usually still connected to the electric grid, and often produce more power than what they need, which they can then feed back to the grid. IEC continues to use its long history highlighted in this clip to push forward for all of the futuristic possibilities in solar cell research and applications. Thank you for watching this clip. We hope you have enjoyed this tour of IEC history.